Hello everyone, this is Mr. H. I have a second video for this week to help with the assignment for the week of June 8th. The assignments that we're working on are proportion, the concept of proportionality, and scale drawings. On Monday, I did a video that I uploaded to my channel, and you should, if you didn't view that, you should probably go watch that. But what I want to do now is I just want to start. I'm just going to do 5 questions, and I'm going to try to go rather quickly because I want to try to keep this short. I seem to go long and kind of long-winded explanations. So let me just go. All right. For Monday, one of the things that we found is that scale drawings are all proportional. Let me say that again. All scale drawings are proportional. When you see the word scale, scale drawings, you should assume proportionality. So I'm going to do 5 problems, 3 from Khan Academy, 2 from iReady, and that's it. So let's go. Well, all right. So the very first thing, also, if you need to understand why they're proportional, just go watch the video for Monday. Okay, so here. This is a scale drawing. It says it here. It also says it here. So now that we know that it's scale drawing, we can assume that it's proportional. And if it's proportional, then we can solve this by setting up a proportion. So let's just do that. It says a scale on a map shows that 3 centimeters represents 10 kilometers. What is the number of centimeters on the map if the actual distance is 25 kilometers? So let's set up a proportion. All right, so if we got 3 centimeters represents 10 kilometers, right? So now we look and they give us 25 kilometers, going to use a different color. So we're going to put 25 kilometers here. And what we're trying to find is the number of centimeters. So that's going to be X. All we're going to do now is cross multiply. So 3 times 25, 3/4 is 75 cents. So 75 divided by 10 is going to be 7.5. That's going to be X. And it's going to be centimeters, 7.5 centimeters, right? Boom. Okay. That's the question. Set the proportion up. Use the units. The units are the easiest way to set up the proportions. Now, sometimes they don't give you the units, or sometimes the units are all in the same unit. So it's a little bit more difficult, but you can still do it. So here's the second example. In this problem, we have 2 figures that are basically drawn to scale from one of the others. So figure A is the scale image of figure B. So this one is an image of this one, okay? We see the word scale here, so we know there's proportional. But look there's no units for this. But what you should be able to see is that this side corresponds to this side. This side corresponds to this side. So just set the side, use the sides to show you how to set it up. So we can go X is proportional to 7.2. And then going to switch it. We're going to say this side is proportional to this. There's our proportion. We've got it set up. It doesn't really matter how you set your proportion up as long as you're consistent with what you're doing. This goes with this, and this goes with this. As long as you do that, you're going to be good. Now, all we're doing is cross multiplying. So this is going to be 3 times 7.2, which is going to be 21.6 divided by 4, and that's going to be 5.4. So the answer for this question is going to be 5.4. Okay, that's it. If you're not given units, use the other clues, use the sides. One of the things that I always teach my students when they're dealing with geometry is try to make sure that your figures, if they're similar or if they're scales with one another, make sure that they're oriented the same way, and these 2 are. Okay, so now let's go, next question. All right, so here I had a triangle before and I got rid of it. So let me see if I can draw that back. Okay, it should be here, here, and then here. All right, so let's read the problem. And I'm gonna draw another triangle here because we're gonna need that too. Okay, so now the problem says, Alexander is drawing a map of the Federal Triangle in Washington, D.C. The actual Federal Triangle has a base of 3,000 feet and a height of 12,000 feet. Alexander needs his drawing to fit on his paper, so he decides to make the base of his triangle 10 inches. Now, what scale is Alexander using? Now this problem didn't give us a scale. We're trying to figure it out. But we always know, since we're dealing with the scale, that this is going to be a proportional, we can use a proportion to solve this, and that this is proportional. So let's look at the actual drawing down here. All right, so it says that the base of the triangle, so that's going to be this. This part here is the base. They said it's 3,000 feet. And the height, which would be here, is 1,200 feet. All right. So now what Alexander did is he drew a triangle and he said the base is going to represent 10 inches. So now what we're going to use is this base and this base go together. So we're going to go 10 inches over 3,000 feet equals 1 inch. Inches go on top to X. That's what we're trying to solve. The box is what we're trying to solve. Now all we're going to do is cross multiplies. So we're going to go and so this is 10 times X will be 10X, and 3,000 times 1 is going to be 3,000. Now all you have to do, because we want to get X, we want to solve for X, so we're going to get rid of the 10 by dividing by 10. And this cancels, so we got X equals 300. So the units are 300 feet. So that's what we have here. Our scale is 1 inch represents 300 feet. Okay, that's all you're doing. Set up the proportions using the units and then solve for whatever you need to solve for. Now, the second question is, what is the height of the triangle in inches? We know what the actual height is. It's 1,200 feet. That's what they told us. We want to know, what would the height be on the model that we're using? What's the height going to be? So let's find that. So what we're going to do, let me get rid of some of this so we can do our next proportion. So what we're going to do is we're going to use this and set up a proportion again. We have the scale now, so let's use it. It's 1 inch represents 300 feet. And then over here, we know that the actual height is 1,200 feet. So we're trying to figure out what what's the height of the drawing going to be. So there's a lot of ways to do this. We could cross multiply. I'm gonna show you something that I like to do, especially when the numbers are nice multiples of each other. So if you look at this, if you multiply 300 times 4, it'll give you 1,200. So that means since we multiplied the bottom by 4, we have to multiply the top by 4. Remember my discussion on Monday and how when you're looking at two things and if they're proportional, if you can multiply one of the figures by a number and get this other corresponding figures, then they're proportional. We know these are proportional. So if we multiply the bottom by 4, we should also be able to multiply the top by 4. So the answer for this one is just going to be 4 inches. So because 4 times 1 is 4. So that's our answer. All right, let's go. Now, this is from iReady. Let me write that. I need it in red because it's hard to read it. So this is from iReady. Okay, so let's read it and let's solve it. It says Mag's got a scale model. I'm gonna circle that word. Model of a jet plane from an online auction. She looked up the real length and found the jet to be 65 feet. So the actual length of the jet is 65 feet, right? If the model scale is 1 foot to 5 feet, how long will the model be? Now, if you look at our scale, something down here, the units are both the same. So we can't use that as a clue on what goes on top, what goes on bottom. So we're gonna have to go to the next level. So it tells us that the model is 1 foot and the actual length is 5 feet. So we're gonna say 1 feet on top, or 1 foot on top, that's the model. And then the actual or the real length is going to be 5 feet. And then over here, we know what the actual length is. It's 65, so that goes down here. And then we're trying to find x. All we have to do now, cross multiply. So this is going to be 65 times 1, which is 65, divided by 5. And that's going to be 13 feet. So the model length would be 13 feet. And that's going to be your answer. I hope you guys can read that. Probably should have used red, but this is going to be 65 times 1 divided by 5 gives us 13. Okay, last question. This is also from iReady. Let's go. It says vector's map has a scale missing. So we're missing the scale drawing, or the scale. They didn't give us the scale. He knows that the distance from the lake to the youth center is actually 8 miles. So the real distance, the actual distance is 8 miles. On the map drawing, they are only 2 inches apart. So what is the scale for vector's map? So basically they're saying the actual distance from the lake to the youth center is 8 miles, but on the map is represented by 2 inches. So you're going to use that. Let's make this red. It's going to be 2 inches over 8 miles. Now we need the scale. We got to figure out, they gave us 4 choices. So all we have to do actually is just simplify this, right? So if we divide 2 by 2, we get 1 inch. If we divide 8 by 2, we get 4. So this is going to be if 2 inches represents 8 miles, 1 inch represents 4 miles. You don't really have to do anything special. You should see that, right? They're proportional. So if 2 inches represents 8 miles, then that means 8 miles, and that means that 1 inch is going to represent 4 miles. Now, so here is our scale right here. Now, which one of these choices represents that or matches that? So our scale says 1 inch to 4 miles. This says 1 mile to 2 inches. So that doesn't work. Actually, I like red for this. So cross that one out. This one says 1 mile to 4 inches. We do have a ratio of 1 to 4, but look at our units. It's 1 inch for every 4 miles. It's not 1 mile for every 4 inches. So that the units do not work. Now let's look at the third one. It says 1 inch for every 4 miles. That's what we want. So that's our choice. It is not 1 inch for 2 miles. All right, so the answer for this would be the third choice. That's it. So this week we're just doing proportions. We're working with scale drawings. And every time you see the word scale drawing or scales or drawing the scale, you should say that means it's proportional. If it's proportional, you can solve it, set it up using a proportion, solve it for whatever the unknown is, and you're done. So that's it. All right, guys. Hopefully you can use these questions and finish your assignments. If you need any help, as always, you can text me or email me.